Only the Voyager 1 and 2 probes have so far traveled to the vast void outside of our solar system. Voyager 1 encountered 300 unidentified objects there, which terrified and alarmed scientists who wondered what these objects were and why they posed such a threat to us. Interstellar space is one of the last great mysteries of space travel. Get ready for a journey far beyond the bounds of the known by following along for all the information you need to know about this discovery. Plasma is found by Voyager 1 in interstellar space, billions of kilometers from Earth. In 2012, NASA's Voyager 1 spacecraft achieved a significant milestone in space exploration when it became the first spacecraft to ever reach interstellar space. When Voyager 1 and Voyager 2 were launched in 1977, engineers anticipated seeing this phenomenon. The probe's missions were only intended to last a few years, but after 45 years of inexorable travel through space, something odd occurred last year. Voyager 1 had already been traveling for 10 years when a particle stream approached the threshold of the heliopause. More than 300 unknown particle types were detected by sensors placed precisely where they shouldn't have been, shocking scientists because in interstellar space, particle density declines sharply, and the odd stream looked like a veritable bombardment. This fact was interesting and unexpected. We must understand that the Sun is not a stationary object. Rather, it is a powerhouse speeding through the galaxy at about 725,000 kilometers per hour. Plasma streams coming from the Sun's outer region are evenly distributed around the Sun and its planets along invisible lines. The heliosphere serves as this force field of protection. Without the currents from the Sun, there would be no heat and no life as we know it. But as we are all aware, the particle streams can also be dangerous. Violent solar winds have the power to momentarily disrupt or disable our entire electromagnetic network, causing things like power supplies or telecommunications to fail. These forces and currents of fine particles are remnants from the early times of our universe and are still present in the space between the stars. They interact everywhere they meet other forces or celestial bodies. At the edge of our solar system, there is radiation and strong magnetic fields that threaten us outside of interstellar space. It follows that the discovery of the new particles is both unexpected and potentially dangerous. Of course, it is not to be expected that the heliosphere will abandon us, but we still know far too little about the processes occurring far out in space to be able to predict what will happen. The discovery of electrically charged plasmas in interstellar space and on the outskirts of our solar system was a first for astronomy. The researchers were extremely fortunate that Voyager 1 and 2 reached the heliosphere's outer limits, passed through the heliopause, and finally entered the outskirts of interstellar space at entirely different times and location. This allowed scientists to compare important data. The measurement results of the two space probes show many similarities, such as the density of the particles they measured in interstellar space, which is fascinating. However, both probes also discovered significant differences that raise new questions about how our Sun moves through the galaxy. The average temperature around the Voyager probes is remarkably low due to the hot plasma being so thin and diffuse. Heat-conducting substances, such as sound, can only be carried by extremely charged particle streams. The interstellar medium is nearly 30,000 degrees hot, much hotter than expected. Even though additional spacecraft are currently leaving the solar system, only 2 Voyager probes can broadcast data from the heliosphere at this time. NASA's New Horizons mission is traveling through the solar system at a speed of over 50,000 miles per hour. But when its batteries run out in the 2030s, New Horizons will not be nearly as well equipped as the Voyager twins. Engineers are doing everything they can to keep the 2 veterans in good health, as the data stream will also dry up. So all eyes are still on the Voyager mission. A large portion of the measurement equipment has already been switched off to save power. Only the magnetometers and the plasma meters are currently still active. While the clock is running, the data takes longer than 20. It takes hours to reach Earth, and only 3 incredibly powerful antennas distributed around the world can collect it. When Voyager 1 looked to have entirely lost its bearings, there was a lot of anxiety that Voyager had contacted something unknown. The reason of the issue was found to be Voyager 1's attitude control system, or more, when the scientists and engineers were able to re-establish clear communications with the probe about what had happened in the official final report. A precise flaw in an onboard computer that should have been inactive caused this computer to unexpectedly turn on, even though it had been deactivated for years. As soon as the issue was identified, engineers came up with a quick fix. They sent a signal to Voyager 1 instructing it to leave the flawed system and switch to the proper computer using radio waves, which took almost 22 hours. Extreme coordination was needed for the recovery process to travel back and forth. Although NASA is still committed to this explanation for the malfunction, some independent scientists have suggested that it was caused by an unidentified force. They compared measurement data from Voyager from the zone it was in with NASA's belief that there shouldn't have been much in that fringe area. To travel back and forth, the recovery process required extreme coordination and, most importantly, patience. The researchers had to discover from the measurement data at the transition to interstellar space that their presumptions regarding the true nature of this zone had been incorrect due to turbulence and no remarkable occurrences. No two scientists agree on how to interpret the disconcerting measurement data, and there are still many questions about the structure of our solar system that need to be answered. Astronomers and cosmologists want to learn more about how our solar system moves through space and the galaxy. Fantastic new measurement data demonstrate just how much more we still don't know. Another interstellar probe will shortly be launched as a result. To explore the outer reaches of the solar system and venture into uncharted realms beyond the heliosphere, the mission is intended to last at least 50 years and span several generations. Today's explorers will launch the mission, and their children or grandchildren can then continue the work started in these days, weeks, or years with a probe made specifically for flight. Voyager 1 will continue its journey through interstellar space eternally, even when the data stream runs out in a few thousand years. When the little spacecraft reaches the next star system, who knows? Maybe someone there will wonder where this peculiar component came from. Tell us what you think about this remarkable discovery and how crucial the investigation is. Do you believe there is any danger at the furthest reaches of our solar system?